Lesson 8-4, Properties of Rhombuses, Rectangles, and Squares. By the end of today's lesson, we will be able to successfully use properties of rhombuses, rectangles, and squares. The rhombus corollary. A quadrilateral is a rhombus if and only if it has four congruent sides. So, if ABCD is a rhombus, if and only if segment AB, BC, CD, and AD are all congruent. For the rectangle corollary, it states that a quadrilateral is a rectangle if and only if it has four right angles. So these will refer to right angles. So ABCD is a rectangle if and only if angle A, B, C, and D are right angles. And this one should be a very familiar one to all of you. And the next one should be the same too, the square corollary. A quadrilateral is a square if and only if it is a rhombus where all the sides are congruent, and a rectangle where all its angles are 90 degrees. So ABCD is a square if and only if segment AB, BC, CD, and AD are all congruent to each other, and angle A, angle B, angle C, and angle D are right angles. Example 1. For any rhombus RSTV, decide whether the statement is always or sometimes true. Draw a sketch and explain your reasoning. So here I already have a sketch for you. I want to know if angle S and angle V are always congruent. Well, since we have all sides congruent, or just simply two pairs of sides that are congruent to each other, by theorem 8.3, where two pairs of opposite sides are congruent to each other, then we can say that this rhombus RSTV is a parallelogram. And by theorem 8.4, if RSTV is a parallelogram, then the opposite angles must be congruent. Then angle S must be congruent to angle V. So we would say always. And for part 2, and we want to know if angle T is congruent to angle V. Well, if rhombus RSTV is a square, then all four angles are congruent right angles. So angle T will be congruent to angle V in this case. But not all rhombuses are squares. So we can say sometimes true. Part B. For any square CDEF, it is always or sometimes true that CD is congruent to DE. Explain your reasoning. we would say always, because a square has 4 congruent sides. Example 2. Classify the special quadrilateral. Explain your reasoning. First of all, for part A, this diagram has 4 congruent sides. And second of all, one of the angles is 127 degrees, so the opposite one must be 127 degrees too. So we can conclude that this is not a square, but instead a rhombus with 4 congruent sides. For part B, a quadrilateral has 4 congruent sides and 4 congruent angles. Now this is very obvious that it must be a square. For the following theorems, I would like you to refer to my website as I explain this. Theorem 8.11 states that a parallelogram is a rhombus if and only if its diagonals are perpendicular. And if we look at the diagram to the right here, this means that ABCD is a rhombus if and only if AC is perpendicular to BD. And remember, when we have if and only if, this would be considered a biconditional statement. And if you refer to my website right now, when you prove this theorem, you need to prove both the conditional statement and its converse. So the conditional statement will be if the diagonals are perpendicular, then this parallelogram is a rhombus. Well, I'm not writing a complete sentence. And for the converse, if the parallelogram is a rhombus, then the diagonals are perpendicular. Well, to prove the conditional statement, you would have to first prove actually, if you put x here in between as the intersection, prove that BXC, triangle BXC is congruent to triangle DXC by side, angle, side, and then you can say that by CPCTC, this side is also congruent to this side. And since ABCD is a parallelogram, by substitution, you can also say that the opposite sides are congruent, and therefore it's a rhombus. But if you want to prove the converse, you would have to first state that, or prove that triangle BXC is congruent to triangle DXC by side, since the diagonals of a parallelogram bisect each other, and since it's a rhombus, all the sides are congruent. And then by using the linear pair postulate, you can prove that this is a right angle. So for the full proof for this theorem, please refer to my website. And I did ask you to prove the converse for extra credit points. And for theorem 8.12, it states that if a parallelogram is a rhombus, if and only if each diagonal bisects a pair of opposite angles. So this means that an ABCD is a rhombus if and only if AC bisects angle BCD, so this angle, and angle BAD, so that you would have 4 congruent angles, and BD bisects angle ABC, so this one, and angle ADC. Well, to prove this, let me first write down the conditional statement. So if AC bisects angle BCD and BD bisects angle ADC, then parallelogram ABCD is a rhombus. To prove this conditional, you can first prove that this triangle is congruent to this triangle by angle side angle. Angle side angle. Angle side angle. And then you can also prove that this triangle is congruent to this triangle by angle side angle, angle side angle. And once we have that, we can prove that AB is congruent to AD, congruent to DC to BC by CPCTC, as well as transitive property of congruence. So this may have not been very clear, but so I highly suggest that you refer to my website for the full proof. And for extra credit points, I would like you to do the converse, the proof of the converse. And for theorem 8.13, it states that a parallelogram is a rectangle if and only if its diagonals are congruent. So if ABCD is a rectangle, if and only if AC is congruent to BD. And you can prove this for extra credit points. And there's 2 different ways to do it, and you can refer to textbook 8.4, number 63. Example 3. Sketch rhombus FGHJ. List everything you know about it. So let's do a quick review. By definition, you need to draw a figure with the following properties. First of all, the figure is a parallelogram. And the figure has 4 congruent sides. And because FGHJ is a parallelogram, it has these properties. Opposite sides are parallel and congruent. Opposite angles are congruent. Consecutive angles are supplementary. Diagonals bisect each other. And by theorem 8.11, the diagonals of FGHJ are perpendicular. And by theorem 8.12, each diagonal bisects a pair of opposite angles. So remember, this angle will be congruent to this angle, as well as this one and this one. Example 4. You're building a frame for a painting. The measurements of the frame are shown below. Part A. The frame must be a rectangle. Given the measurements in the diagram, can you assume that it is? Well, opposite sides are equal, but we don't have enough information. The boards on the opposite sides are the same length, so it's a parallelogram, but we do not know if they are right angles. So, no. Part B. You measure the diagonals of a frame. The diagonals are about 25.6 inches. What can you conclude about the shape of the frame? By theorem 8.13, the diagonals are congruent. And when the diagonals are congruent on the frame, then we can conclude that this frame is a rectangle by theorem 8.13. Diagonals are congruent.